Yes, today we will continue first statement. I hope it was clear about the first statement syntax and its execution, and the kind of programs we have done it using for in the last couple of classes. And I've given you some assignments based on the same. I hope all of you have done it, and you are regularly uploading your assignments in the Google Classroom. But I can see very few are submitting. I want all of you to please complete the assignments on time and submit the next day. Okay, and these all accumulated programs executed in the lab session, and okay, shows your execution. Okay, today we will see some more programs using for loop program. We find the entered number is perfect or not. Okay. What is a perfect number definition?
Sum of factors is equal to the number itself.
Yes, sum of factors is equal to the number itself. Good definition. Fine. So given by whom? What is your name?
Funny Priyas.
Anitya, yes. So can you give an example?
6.
Yes, good. 628. Like that, okay. So just elaborate. We'll try to elaborate the definition here on these numbers to ensure how they are, perfect numbers. The definition is sum of factors. What are the factors of 6? 1, 2, 3, and 6. Yes, sir. Factors of 6. So here, when do you say a number is a factor of another number? When that number perfectly divides it. It means when you divide the number with that factor, you get the remainder 0. Then you say it is a factor. Yes. So you can see 1, 2, 3, and 6. They perfectly divide 6. Listen. When you divide 6 with 1, you get remainder 0. When you divide 6 with 2, you get remainder 0. When you divide 6 with 3, you get remainder 0. But when you divide 6 with 4, you don't get remainder 0. Listen, you get remainder as 2. Fine. Similarly, for 5, you don't get. So it's not a factor. 6 is again a factor, right? So 1, 2, 3. Here, I should add something in the definition. I'll correct the Funny Priya's definition here by adding one word in this. Fine, then only my definition will complete. Okay. Sum of factors, I say here because the number itself is also a factor. So I say sum of factors excluding the number. Got it? Excluding the number is equal to the number itself. Got it? If I don't add this, what happens? See, the number itself is also a factor of it, right? Then 1 plus 2 plus 3 plus 6 is how much? Double the number, right? Double, which is not equal. So I need to add this, right? So the definition of a perfect number is sum of factors excluding the number is equal to the number. Fine. Then it is said to be perfect number. I hope it is clear to all of you. It means now, as per the definition which I have modified, then in order to prove that 6 is a perfect number, I have to sum all the factors. I have how many factors for 6? 1, 2, 3, 6. But I will be taking how many factors? only 1, 2, 3, because I have to exclude the number. In the definition I have given, exclude the number, right? So it means 1 plus 2 plus 3. Got it? 1 plus 2 plus 3 equal to how much? 6. The number itself, right? Fine. So similarly for 28, if I see for 28, what are the factors of 28? 28 factors are 1, 2, 7, 14, and 28. Now, as per the definition, yeah. Now, as per the definition, 4 also good. 1, 2, 4, 7, 14, and 28. Good. So, now what is that I have to do in order to prove that it is perfect number? I have to sum the factors 1 plus 2 plus 4 plus 7 plus 14. I don't add 28, right? I have to exclude it, right? So then this total is how much? 28, which is equivalent to the number itself. Yes, sir. So then I can say it is a perfect number. Let us take some other number. For example, you take any other number. 12 you can take. Fine. What are the factors of 12? 1 you get, 2 you get 2 6 are 12. So 3 4s are 12, 4 3s are 12, and 6 2s are 12. Yes or no? And you have 12 itself. Okay. So now when I add the factors of 12, excluding that, what do I get here? 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 6, 16. 16 is not equivalent to 12. Yes or no? It means 16 is not, 12 is not a perfect number, right? So this is not a perfect number. This is a perfect number. If you observe whether it is a perfect number or not, the maximum number of factors that you get excluding the number is ranging from 1 to half of the number. Yes or no? Half of the number. 12 by 66, right? 28 by 2, that is 14. So I can see now while I am devising the logic, you can see how I am going to devise the logic. This is more important. See, by analyzing the problem, the definition itself will have, the complete logic inside. See the definition. Just look at the definition, perfect number. So in exam, if I'm asked to write a program to find whether the number is perfect or not, first thing that I need to know is I need to know its complete definition. Its perfect definition. I got the definition. Then once I got the definition, if I analyze the definition with certain examples, I could conclude that I can find the factors for any number to prove that whether it is a perfect or not, ranging from 1 to half of the number only. You can see 28 is a perfect number and 6 is also a perfect number. For these also, you can see the factors that I have to include are from 1 to half of the number. Yes or no? Here also I have to include 1 to half of the number. Fine. Even if the number is not a perfect, okay. So the kind of factors that I have to include are again 1 to half of the number. It means I can now conclude with the point that the numbers, okay, the numbers which I am going to take to check whether it is a factor of that number or not, and then accumulate the same in order to get the sum of factors, I should take the range from 1 to half of the number. So this is clear to me. Now, based on this, I can devise the logic for it. You can see here I am now devising a logic for it. So I am taking a for loop here. For I equal to the numbers that I may get as factors for the number will range from 1 to half of the number. Yes or no? Half of the number. So that I have taken in I. Now, let us say I am finding the sum of factors in sum. It's a sum of some series. No, in some series kind, the initial value will be 0, and now you accumulate all such terms to the sum in order to get the sum of that particular series value, right? So before I add it to or accumulate it to sum, I need to check that number is a factor or not, because I have the numbers ranging from 1 to half, but they are all not the factors, right? There could be some factors and there could not be few. So in order to determine whether it is a factor or not, how do I do that? I need to divide.
Modulus.
Yes, I need to divide the number n with this I and check that the remainder is 0, right? So what n mod I does, n mod I give me the remainder out of this division. It means the numbers which I am trying to ensure that whether they are factors or not, which I am taking in I. Okay, so they are the divisors, yeah, and I am taking that as a divisor and dividing the number with all such divisors, and the remainder out of it I am checking whether it is 0. If the remainder is equal to 0, it means I is a factor of n. Then I will be accumulating it to sum. So I say sum equal to sum plus I. Got it? Sum equal to sum plus I. That's it. This is my logic. Now when I come out of the loop, I can find the sum of factors excluding the number, because I have restricted till the half of the number. So there is no chance that I am going to take the number itself. Got it? So my value range is between 1 to half of the number. Okay. So that I have analyzed with certain examples. Fine. And I am confirmed that. So I need not to check the numbers after half of the number, because after half you don't have any factors in itself, rather, right? You will have factors for any, whether it is a perfect or not, will be from 1 to half of the number. So where I can find the possibility, only those range I have taken. Right. This is also a part of, identifying the problem analysis. Okay, fine. Okay, so now when I come out of this particular loop, I can find the sum of factors excluding the number in sum, and the original number is in n. So if I compare these both, right, I can then say that if both are same, it is a perfect, right? Yes or no? If n equal to sum, I say it is a perfect, else I say not a perfect. Got it? This is the logic, right? So once if you can devise the logic, now writing algorithm program is not a big thing. Fine. What is that you have to do in order to write algorithm, flowchart and program? Fine. You first have to identify the variables you require. Fine. Here you have I, sum and n. Okay. Then what are their type you need to identify. Then declare them first. Declaration is the first step. Then what do you do next? You will identify the inputs. What is the input? Number is the input. You do the initialization of it. Next part is done. Then what is the next step that you do? You will apply the logic. This is your logic. Okay. Fine. And you're going to print the output. So by comparing n value with sum, if they are equal, you say it is a perfect. It is otherwise you're saying it's not a perfect. Got it. So now let me write the algorithm for the same. I hope all of you can write the algorithm for what I have just now discussed, right? I hope all of you have understood how to write algorithm, how to draw flowchart, how to write the program. Yes or no? Yes, Fanipriya?
Yes, sir.
Yeah. So anyway, I'll show this.
Yes, sir.
Yeah. So I am leaving algorithm and flowchart to you. Okay. I'll just write the program and demonstrate it in the online compiler for this. Okay. Yes. So how do I log in to online GDB? I just say login here. And then I say Google Plus. And then I'm logged in, right? I got with some skeleton. I can start using it, rather, right? So first thing that I do is the declaration. Fine. Int. What are the variables I require? I, comma, n, comma, sum. And sum I want it to be with an initial value 0. I can initialize it at the declaration part like this. Got it? Next thing is after I declare, what is that I have to do? I have to accept the input. So enter the number. So I have accepted the number. Now my logic starts. So what is the logic? For I equal to 1, I less than or equal. Here if I miss equal to, n by 2 will not be considered. So I have to take here equal to, right? I less than or equal to n by 2. Semicolon I plus plus. Now inside for I have a single statement, so I need not to have a braces. I can just straight away say this. If, what is it? If n mod I equal to 0, right? And again inside if I don't have a much statement, I have a single statement, so I need not to have braces, right? If n mod I equal to 0, I say sum equal to some place I. When I have the left side operand and the left hand side resulting operand, both are same, I can use shortcut operator. Sum plus equal to I. What do you mean by this? Sum plus equal to I means sum equal to sum plus I. Okay. When you have left operand of the binary operation and LHS part, both are same, you can use shortcut operator. This should be shortcut operator, right? We have discussed in I think operators in shortcut operator under arithmetic operators. We have discussed this. Sum plus equal to I can say, right? Just to reduce the code, I am using this, all right. So now when I come out of the for loop, I will find the sum of factors to number in sum, and the original number is available in n. That I have to check now. If n equal to sum, the number and the original sum of factors, explain number, both I am comparing here. If both are equal, then what is that I'm going to print here? I am printing that the number which I have inputted is a perfect one. Okay. Else what do I say? Not a perfect. Else I say that
Sir, we need to include the variable, no, sir, and format specifier after format specifier.
yes, good. So here I have to include, in place of this percentage d, what do I want to print? I want to print n, right? So I have to say n here. Similarly here. Okay, now the program is completed. So you can see in the program, first part is declaration, where we have declared all the variables I and sum, and I have initialized some value with zeros. Then I have accepted the input n, enter the number, and then I have set scanf. Then I have the logic. This is the logic. Then we are trying to compare the sum of factors which we have obtained from the for loop with the original number. If they are equal, we say it is a perfect. Otherwise, we are saying it's not a perfect. Right. So now we can save the program first. I can say perfect, right? Perfect. Using for. Save it. Choose the language as C. Then run it. So it is asking for a number. Just take number 6. You can see 6 is a perfect. All of you can see it, right? Fine. I'll again execute and give a number which is not a perfect. Okay, and we'll test. I'll give some number 8. Okay, 8 is not a perfect. You can see the output it has given us 8 is not a perfect, right? So see, this is called testing. So after once you write, basically what happens is first you do analysis when the problem is given to you. Fine. So based on the analysis, you devise the logic. So here what we have done, you can see based on the definition or the facts or data, we have tried to devise, we have first analyzed. This is called analysis process. Then out of this analysis, we could, devise a logic for it, right? Once you develop a logic, you can write a program for the same. Here we have written the program, right? Then we are testing whether it is working for all or not, right? I have given one perfect number, another one is I have given as not a perfect. So for both of them, it is working, right? So this is called testing. This is how in industry as well, the projects are going to be created. These are the different phases you find. First phase is requirement capture. Requirement capture includes your definition, your facts, figures, data, and all. See, if I ask you to write a program to find whether it is a perfect or not, if you do not know the definition, you cannot move ahead, right? You cannot start rather, right? So in order to do that, you need to first of all understand what is a perfect number. So for that, you need to do some study. That is said to be the literature survey, right? That is said to be the requirement capture phase, right? So where you are trying to first understand the problem, you are trying to understand the definition, you are trying to understand and then collect the facts and figures from it, right? So that is the first phase that you do. The second phase that you do is you will analyze the problem with certain data, then after you analyze, you will then devise a logic. This is said to be designing, right? Designing process, analysis, requirement capture, analysis, and design process. So once you design, you will apply using some language that is said to be your implementation, right? The program writing is nothing but implementing that particular project, right? So it is said to be implementation phase. And then after you implement, you will test it. This is how we have tested, by executing it, rather, right? Then you will have another phase to be the maintenance. Maintenance in the sense, if any adoptions, corrections are probably required in future, right? It may be working for a few possibilities, but then in latter case, let us say some more few possibilities came into being. Let us say, for example, negative numbers or other kind of requirement has come. For that, you need to have some kind of maintenance process. This is said to be the maintenance process. So any project you take up, right, in industry, you will have these many phases, right? Requirement capture, analysis, design, implementation, testing, and maintenance. So in this subject, we are not just learning C programming language. Learning C programming language is just nothing but learning the syntax of C, fine, which probably you can find in any reader or my material available in the website or on any Google platform or any by googling you can find out a lot of material on it, right? And a lot of YouTubes are also available. But that is not what exactly you are learning in this subject. Programming for problem solving, right? You first are trying to identify a problem, and if the problem is identified, you are solving the problem. Then the solved problem, you are trying to implement it with the help of programming using C language, right? So these all things are being covered as part of this particular subject. So it is not just a program when I say your subject is rather, right? It includes all these phases which I have now discussed. I have shown you as well for this particular problem which I have taken up. I have shown you what are the different phases in order to execute this particular task, right? This is my requirement capture phase, right? This is my analysis phase for this problem. This is my design phase, and then you can see this is my implementation phase, and this is my testing phase, and adoption phase is said to be the maintenance. That is when someone else is suggesting some changes to this, you need to be always ready to do it and make it as per his requirement as well, so that your product will be always, saleable. Okay, fine. So, okay, we'll now move on our next topic. Anyway, I wanted to take up a good number of problems on this control statements. Reason is control statements, you know, is the building block of the programming language. Any programming language you take, right? It is the building block of the programming language. So when you understand these control statements quite well, fine, you can be able to devise the logic for any problem. See, if any new problem is given to you, in order to solve that, if you must have already solved some of such kind of similar problem, it will be easy for you. Otherwise, it will be always difficult for a person to start from the scratch. That is the reason why what we do, we try to work on more number of examples, right? That gives you a versatile thinking, so that you can probably able to devise the logic for anyone always, right? So that is the main intention. See, there can be thousands of programs, we can probably implement. It's all based on your interest that you can rather do it. But of course, as we need to cover the syllabi as well, okay, so we'll try to ensure that maximum number of programs are being covered under each programming construct, which gives you a good thinking ability or creative ability towards problem solving, right? But in order to get expertise, you need to take an initiative again from your side as well, and what all assignments we give, I am giving you, so that all you need to solve. And if you have any doubts from from them or while solving them, probably you can always contact me through WhatsApp or through mail as well. Okay, we'll move on to the next program here. Write a program to print Fibonacci series. So when the problem is given like this, first you need to understand what is Fibonacci series. Yes, anybody?
1, 1, 2, 3, 5, and so on.
1, 3, 5.
Yes, here the Fibonacci series starts from 0, 1, 0, 1, and the subsequent numbers are sum of its preceding two numbers. Sum of its preceding two numbers. Then how do you get the series? When you start with 0, 1, the subsequent number, it means the next number, you will get by finding the sum of its preceding two numbers. 0 plus 1, okay, and the next one is 1 plus 1, next one is 1 plus 2, next one is 2 plus 3, next one is 3 plus 5, next one is 5 plus 8. Got my point? So this way you will find, right? The subsequent number is the one which you are trying to find. How do you find? By taking the sum of its preceding two numbers. These are the preceding two numbers of the subsequent number. So you add them, you will get it, right? So you will get 21, like this. So this series you want to print. So before you write the program, you need to first analyze. Okay, you got the requirement, you got the data or facts and all definitions, you understood. Now you try to analyze this. When you analyze this, what is it happening here? Let us take this as f1, let us take this as f2. Okay, then how is that I am going to find the f3? Let us take this as f3. How do I see? Look at the initial and the changing values. Initial are 0, 1, and changing value is here. You can see third one. Fine. So I have taken two variables here, f1, f2, to start with the initial values, and the changing value I wanted to get it through f3. But then from the next phase, next iteration, you can find the initial values are also being the variables which we have used to indicate the initial values are also going to be rather changed. So this you have to identify. Then you can probably devise the logic for it. So here you can see, how did I get f3? How do I get f3? By summing up the f1 and f2, right? So how do I get f3? By summing up f1 and f2. Got it? So that's good. Then in order to get this, this has to be f2 and this has to be f1. When f2 is changed to f1 and current f3 is changed to f2, then again same formula, if I apply f3 equal to f1 plus f2, I get the next number. So it means I need to change the f1, f2 values as well here, right? So you can see here, what is f2? f2 should be f3 and f1 should be f2. So I say that f1 equal to f2, I took the f2 value in f1, and f2 equal to f3, when I say the current f3 will be taken into f2. And if I repeat the same again, I'll get next number in the series. Yes or no? Next number in the series. When I again apply the same formula. And this I can repeat for how many times, how many numbers you want in the series. Let us say you want n numbers in the series. Okay? Or say less than n number. You can here devise the logic and define the restrictions. It's up to you. Fine. Whether I restrict it with less than n or with certain n number. If I restrict it with less than n, it means if I say less than 25, it will print me till 21. Fine. If I say print all n numbers means n, let us say for example 10, if I say, then it's going to print 1, 2, 3, 4, 5, 6, 7, and the next, and all, right? So how you are going to devise the logic? That is also one part. Let us say if I want to restrict it till less than n, I'll get one logic. Or if I have to generate n numbers in the Fibonacci series, I'll have to devise with another logic. I can go with either of them, right? Both of them are correct for me, right? When the question was asked like this, if the question was asked like to restrict it to less than certain number, then the logic has to be like that. Or if the question was asked restrict it with n number or generate with n numbers, generate series with n numbers, then you have to go with this logic, right? So here you can see I am going with the second one, right? So I want to generate how many n numbers in the series. So then what do I say? I equal to 1, I less than n, right? I less than n, I plus, right? Here I am having more than one statement in the block, so I should have to take the open brace, right? This is my logic, that's it, right? See, what happens now here? Let us say, for example, n is 5. Okay, initially what is F1? 0, and what is F2? 1. Okay. So F1 is 0, F2 is 1, and F3 we have some garbage value. When you just declare and you do not initialize, what will be there inside? It is some garbage value rather, right? So now let us execute this. I have devised the logic. I want to test the logic, right? See, at the design part as well, most of the projects are going to be tested. So testing at the design is nothing but tracing the logic and ensuring that it is working to our requirement, right? So that I am doing here, you can see, right? See, I equal to 1. So I equal to 1 is going to be done, because for loop, how does it get executed? First initialization, then the condition is going to test it. 1 less than n. Fine. So 1 less than 5 is true. Then you will be allowed inside. Then here, what is that you want to do? F3 equal to F1 plus F2. F1 plus F2 is 0 plus 1 is going to be, that is 1. Then you are printing F3. Here I am using, you can see, an offset, right? This is said to be offset. If I want to have some space in between the numbers which I am going to print in the same row, I can use this, right? Instead of just %d, I said %4d. So when I say 4d, 4 spaces will be reserved. 4 spaces will be reserved. And then F3 value is going to be printed with right justification. So what is F3 here? 1. So before which 3 spaces will be left empty. So similarly, next number when you print, there will be 3 spaces in between. So in order to differentiate, because if I print all these numbers together, then it looks whole to be a single number rather, right? When the digits are, just adjacent to each other. In order to separate it, we will be using the delimiter as space. So you can use space as a delimiter to separate the numbers so that you can show the series here rather, right? So for that you can use this offset. Anything you are printing, whether it is a character or integer or float long double, with the form specifiers, you can use this offset, right? %4d, %3d or 5d, how many spaces you want, you can, based on that you can mention here. Fine. So I'm using that offset here, rather, right? %4d. So 3 spaces I get in between 2 numbers. Fine. So after this printf is executed, what is the next statement I have? F1 equal to F2. Means F2 value will be placed in F1. It means that F1 gets F1 gets 1. F1 was having earlier 0. Now it is replaced with 1. And then you say F2 equal to F3 means F2 gets F3 value. It means F2 gets replaced with F3, which is nothing but also 1. Again, you go for the next iteration. When you go for the next iteration, what happens? I gets incremented, I value will be true, 2 less than 5 is true. Then you will be allowed inside. Here, what is that you're doing? F1 plus F2, that is 1 plus 1 is going to be 2, which is going to be placed in F3. So, in F3. The next is you are going to print here, right? Next statement is print. Print %4d means 4 spaces you are reserving. Then with right justification, you are printing the F3 value. So you will get 2 here, right? You get some spaces in between, right? So after this, F1 equal to F2, when you say F1 gets F2 value, and when you say F2 equal to F3, F2 gets F3 value, then again you go for the next iteration. I gets 3, 3 less than 5 is true, fine. 3 less than 5 is true. Again you will come inside, then you say F3 equal to F1 plus F2, it means what will be the F3 value? 1 plus 2 is going to be 3. So F3 gets 3 here, and that you are going to print with the 3 spaces leaving in between, right? Then after this, F1 equal to F2 means F1 get replaced with 2, and F2 equal to F3 means F2 get replaced with 3, and then you go for the next iteration. I becomes 4, 4 less than 5 is again true. Then you will be again allowed inside where F3 equal to F1 plus F2 you are doing, which is nothing but 2 plus 3 is going to be 5. So F3 get replaced with 5, and 5 is going to be displayed with 3 spaces in between. Then you have the next statement is F1 equal to F2. So F1 get replaced with 3, and F2 equal to F3 means F2 get replaced with 5. Got it? Then you go for the next iteration. I plus plus. I gets what? 5. 5 less than 5 means false, you come out of the loop. So here I am able to print only 4 numbers. If I have to print 5 numbers, I should say equal to here, right? So if I start with 1, I should say equal, so that I get all n. Fine. So now I have modified it to equal, so that I can include the 5th iteration as well here, rather, right? So I value when 5 less than equal to 5 is also true. Again, you are allowed inside. Then f3 equal to f1 plus f2 means what f3 value you get? 3 plus 5 is nothing but 8 here, and that is going to be printed with 3 spaces in between. And f1 equal to f2 means f1 get replaced with 5, f2 equal to f3 means f2 get replaced with 8, and then you go for the next iteration. I becomes 6, right? 6 less than equal to 5 is false, and you come out of the loop. You want to generate how many numbers in the series? 5, and you can see that, right? 1, 2, 3, 5, and this is Fibonacci series as per the definition. Because you can take any number, you will find its value by taking the sum of its preceding 2 numbers. Got it? So the logic is now available. You can write the program. Fine. All of you can write the program. I think you all can write the program. So write the algorithm, flowchart, and the program for the same. Okay. Do you want me to show the program for this? Okay, let us do the program as well. What are the variables? So while writing the program, what is that you have to do? First, you have to identify what variables you have. You have f1, you have f2, you have I, you have n. So you have to first declare by identifying their type. Then the input. What is the input here? N. So taking that as an input, you will be accepting it rather, right? Then you are going to apply this logic, right? Implement this logic. The logic itself is going to print the output here rather, right? So I am first declaring all the variables that are required. I, comma, n, comma, f1, comma, f2, comma, f3. And f1, f2 value should start from 0 and 1 respectively. I can do that initialization part at the declaration itself, right? f1 equal to 0, f2 equal to 0. Okay. Now you want me to print that f1 and f2 as well. You can print that saying that Fibonacci series right? So you will be printing first f1 and f2. You can print it here itself. Start printing. You can. It is anyway 0 and 1 start with. So 0, or you can say percentage d, and then you can say f1 f2. That is also okay. Or since you know it, you can just display it 0 and 1. Fine. Then here the logic starts, right? So you have a for loop here. This for loop, I'm taking it to generate how many numbers in the series? N numbers in the series. So I equal to 1 if I say I less than or equal to n. I plus plus.
Sir, we need to read n.
Yes, you need to read n here. So we will first, after declaration, read the inputs here. Printf, enter the number. I say enough percentage D comma ampersand N and semicolon, right? So here the logic starts. I have more number of statements, so I should take braces here. Then my logic here starts. F3 equal to F1 plus F2. Then I'll be immediately printing that because I need to change the F3 value as well. That's the reason why I need to print it immediately. So, but here before printing, I'm taking some space. Okay. With offset, I can have some space. So instead of percentage D, I'm saying percentage 4D here, so that some spaces I get before I print that number, right? Then F1 equal to F2 and F2 equal to F3, right? That's it. That is my end of the program. Got it? So you can see here, we have first declared the variables by identifying their type. Then next is we have accepted the input. Then our logic is, right? Logic itself is including the print. So you can see the program first, saying it is Fibonacci.
Sir, F2 equal to 1, sir.
Yes. Yes, good. So you are not sleeping. Good. I'm happy to see the responses from you. So F1 equal to 0, F2 equal to 1. Good. So now the program is saved. Okay. So we can now execute the program. Language is already chosen as C. You can see.
Sir, return 0 is not there.
Yes. Now you can see there are certain, errors. Why these errors are? You can see I have given the braces which are not required because already they are there. Got it? How many opening braces you will have? Same number of closing braces you should have. See, I have one brace here. This is the opening brace of main. This is the closing of the same. This is the opening brace of her. This is the closing of the same. But before that, I had two more. That's the reason why I got the error. Now again, you execute it. You can see the output. Fine. Enter the number. So how many numbers you want in your series? I want to generate a Fibonacci series with 5 numbers, let us say, including my 0, 1. Okay. 0, 1. You can see the next is 1. Again, the sum of these two is 2. The sum of this is 3 here. The sum of this is 5 here. The sum of this is 8 here. Fine. So based on the number which I give, 0, 1 anyway I am printing. So the subsequent numbers, I am generating it with the help of logic, right? So how many numbers I want to generate after 0, 1, that I am giving in n. That will be generated here, okay? I hope this is clear to all of you. Yes?
Yes, sir.
So you can write the algorithm, program, and then flowchart also. You have to do all these 3 things.